Was it always the case, or what happened here? But when I open a random problem, it will be white, right? Okay. That's, well, not very consistent. Still maybe a step in a good direction. So yeah, let's sort by the time. The last few problems are locked. Hi guys, hi chat. So what? Warm-up problem? Hi Samrat, Twishiba. Hi everybody. Product difference is difference of products. We need to maximize the product difference. I guess that minimizing the difference will be more difficult. But if we want to maximize the difference, then you will need to go big times big minus small times small. I even guess that we need to choose two smallest and two biggest. Oh yeah, and today I can also do some problems from binarysearch.com. So always I allow you to suggest problems from LeetCode. Today we can mix a little bit. A little bit of both. How long have I been coding? 10 years. I wonder if we can solve this problem for those constraints if we want to minimize the difference, but I don't think that's possible. Oh, wait, before I start coding, I need to just ping on Discord. I feel bad about not using my Discord server recently. Alright, Discord pinged. Hi chat. So this is the link we are solving, but I think I will sort, but we can do it better without sorting. We can find two biggest and two smallest, and they claim that we need to find two biggest. This is one way to get the biggest. To get the second biggest in C++, for example, this is how we can do it, times the product of two smallest. Will it work? Does it work here? 7 times 6 minus 2, 4. Yeah, that works. Submitting without testing on sample tests. All right. Now, if we wanted to minimize the difference, then I could gather all the pairs, so all the products, and I would sort it. Right? And then I have a sequence of products, maybe 4, 6, another 6, 8, 9, 10, maybe next one is 15, 16, and so on, out of products. And now it will be nice to take two consecutive ones here, like perfectly 6 minus 6, unless they use the same numbers. So not only I need to know the values, but also from where they come. I guess indices. So this is 4, and it comes from index 0 with index 2. This is 6 with index 0 and index 5. Then I cannot take those two. When I look at every number, what I'm doing now is, what if we wanted minimum difference? When I look at 6, I need the last element, the most recently visited element, without my ij. With negative numbers that would be more interesting. I agree. I agree. Yeah, that's the second question we can think about later. What if there could be negative values? But still, this one is harder. Still, I just hope that we can do it in n squared times log of n. I don't know if that's possible. We need to find the most recent value without the same I or j. If it was without the same I, it would be easy. I would store two best indices so far. Maybe it makes sense to imagine a two-dimensional grid n by n, like this. Like one dimension would be I, the other dimension would be j, and then when you see that there is value 5 here, you want like the closest value not in the same row and not in the same column. That can be done with segment trees, but it's complicated. Hash all the n squared pairs and then find the closest pair product. Well, how? How do we do that? How to find the closest pair product? I don't even need to hash. I can have an array like value n by n. So for every pair ij, I can know the value. Why wouldn't the answer be negative of maximum? Oh, I don't know if, maybe it wasn't specified here. But of course, I mean the absolute difference then. So we minimize the absolute difference of a times b minus c times y, c times d. Absolute value of this difference. Loop through all the pairs again. If you want O of n4, then I agree that it's easy. You don't need any hashing. But so this, of course, is easy. This is brute force. O of n squared, I think, is very hard because for every pair, how do we find that closest? It's not that hashing allows us to easier detect objects other than something in the same row or column. Yeah, so I think that what I can do is use some complicated structures like segment tree, merge tree, something like that with sets, and then we will have this, maybe log squared. I'm not sure about that, but I'm interested in n squared or just n squared times log r, something simple. Since when does n minus 2 work? Since always, actually, but I agree that not a lot of people know about it. This is a pointer, just like when this, like a is a pointer, right? This is the same kind of pointer. The type of what I marked here is the same as the type of this, a. Both are pointers. When you put brackets, you just say that I want to value in this array at this position. So, but this also could be a.begin plus 5 or something like this. And what you put here before brackets is a pointer. And then it will be shifted by whatever you put here in brackets. Binary search for an array. You cannot binary search because how do you know if you should go left or right? For some solution, well, but okay, so maybe we should not think about pairs like this black box that came from some values ij, but instead we should iterate smartly. In for sum, but for sum is easier. For a particular pair, you know exactly what you see missing. Like in for sum, if you want to get the sum of 4 numbers equal to, let's say, 100, and you already have 2 numbers equal to 40, then you know that you want the remaining c plus d to be equal to 60, right? If you have this for some pair AB, then you want that. And you can have a map that for value 60 will tell you if you already got this map or a set. But here, this problem, if we want to minimize the product, the difference between products, it's harder because it's like here saying that we want to be close to 60. So this will be possible in n squared times polylog, so log or log squared, but it's not easy. Minimum difference comes from 4 consecutive elements? Not necessarily. Maybe if you take far away elements, still the products will be close. So, Bessie, this idea you're saying, it works for sum because here the order of ABCD doesn't matter. But for the product, if you say A times B needs to be close to C times D, then suddenly the order matters, right? So it's not that you have a sequence and when you have A here and B there, you can say that C and D you will take from there. That's not correct. With some transformations, maybe it will be correct. Like if you also consider that you want A over C to be close to D over B. Yeah. So the title is LeetCode is easy, so we will not go there. Yogesh, I assume that the array is sorted, but still, so what? You can just have pairs that are values that are before. Yeah, but it's not that you need this order. Okay, so what you're saying is that for AB with product equal to 40, you will want product equal to 40 here. Let's say C and D. But that's not enough because it isn't said that A and B should be more to the right, say bigger, than CD. That's not true. And no, it isn't true that it will be best for consecutive numbers. I can show you an example where it will not be consecutive numbers. 1, 2, 3, 6, 18. Is that a good example? Not really. Multiply everything by 10 and say that this is 19. Right now you will have two closest products if you take 10 times 180 and 30 times 60. The product will be the same. So it's not 4 consecutive. This 19 stands in a way. And here it's optimal to take a pair AB, those two, and you cannot say that CD are taken from before, from the left from AB. Not true. I-B, yeah, that's true that we can do this in linear time. So here I solved it easily in n log n, this problem on the left. This is easy O of n times log of n. Possible O of n, sure, because we can find two maxima and two minima in linear time. What I'm doing here below, and I moved this question there, is harder version of a problem. What if we wanted minimum difference? And I think that it's possible. I even once created a similar problem for topcoder, but it's just harder. It's way more complicated, so we will leave it here. Problems related to evaluating expressions. I for sure solved at least one of them in the past during my streams. It's some recursion. So Jarvis, you should Google something like this. I know, parsing expression tutorial, something like this, and you will find it. So space. You don't, if you sort something, you don't need to binary search to find the closest product. If you have, here I even wrote something there. If you have a list of sorted products, you don't need to binary search anything, because after sorting, if you see 9, obviously two closest are 8 and 10, but maybe they use the same number, maybe they use the same index. So what we need to find for such value 9, such product, is closest to the left and closest to the right without using the same index. And you cannot use binary search for that. Because how will you will look here, and how do you know if on the right, so in this interval, there is something without using I or j? So no, we cannot binary search here. We could binary search if you want, if we could say, if we go left or right. And obviously, not to make this trivial, when I say minimum, I don't just say the opposite of maximum. I want them to be closest, so closest to products. I specified it, I guess, here, minimum of absolute value of the difference. I'm not solving this because it's difficult. Like, I see how to go in that direction, but this is, in my topcoder round, it was topcoder medium, so it was way harder than any LeetCode problem. I can actually try to find it if you want to practice something related. We want division 1, I believe 2. Nope. Nope. Here you go. A times C is equal B times D. What was that? For scores satisfying this, we want to find a subsequence of size 4 satisfying that. Now I think that it's easier than topcoder medium, but still, that's your homework if you want something similar. We want to find such 4 elements, A, B, C, D, that A times C is equal B times D. And this is harder than standard for sum, because they are mixed. It's not. It would be easier to say AB is equal CD. Blue on blue is not a good idea. If you have 4 elements, A, B, C, D, if you want to split them like this, and you want to say, for example, that A plus B times B is equal, even C plus D, they don't even need to be the same type. This is easy. You can use the same trick as from for sum. There is this problem, and I'm sure you will find in the internet some tutorials about it, where it's, I would call it meet in the middle, where in some kind of map, if you have information about pairs in prefix, then for every pair in the suffix, you will use that map, you will access it. Then this is solvable in n squared time, if you use hash set. But once you mix up the order and you say A times C or A times D is equal to the other two, so instead of this, if we go, I shouldn't have erased, but now harder version is, like, for example, AC is equal BD, or A times C is equal B plus D, anything like that. Right? This version, that's harder. How often are these streams? How long? Around 3 times a week for around 90 minutes to 2 hours. It's usually 2 hours. On purpose here I said C plus D, because I said it doesn't matter. No matter what operation you put here, you can put XOR, you can put divide, any operation computable for a per CD, you can figure out, like you can use, and this is still solvable in n squared, as long as this is some operation you can compute in constant time. Is it asked that indices ABCD should be in sorted order? It is in this problem. In this problem we say A times C is equal B times D. And it makes things more complicated. No, I'm not doing topcoder today, and actually I'm moving on to a different problem now. Just we had this, and then I went on a tangent about different version of a problem. Now somebody, so let's move this away. If you want to practice that, look up the problem bear darts in topcoder. Once again, this is the link. Somebody here suggested a different thing. If we here, now back to this very easy problem, if we want to maximize the difference of products, and for now we took two biggest numbers, the product of them minus product of two smallest, that worked because values here are positive. Now what if the values could be negative? The question is, what if negative? Is any logarithm log2 in time complexity? Binary search. If there can be negative elements, then this product is not necessarily small. Like minus 10 times minus 11 actually makes this big. It can even be biggest. Still, we want to here have a big product minus something small. And then perfectly you want to say x times, well, still, we want this, right? And we want to maximize this. So this perfectly should be small negative value. We will get a good result if we do something like 20 times 30 minus 17 times minus 22. This will be very efficient. And this will be big because this negative number actually gets here multiplied by minus 1. So let's think about it differently. We maximize A times B plus C times D after first multiplying one element by minus 1. Right? We multiply C or D by minus 1. So we got to a new version of a problem. You don't see it. Here we go. You're allowed, or actually you need to multiply one element by minus 1, and then you want to maximize this. Yep. And then I claim that most of the time we use 3 biggest elements and the smallest element. For example, if the sequence is minus 22, minus 18, minus 5, minus 1, 7, 17, 20, 30, then the best product, the best difference of products will be made out of those 4 elements. It will be something like 30 times 20 minus 17 times minus 22. Maybe here we should slightly modify the order depending on the situation. Maybe this should be 20, this 17. I think in this case that order was fine. Because 30 was big, so we want to put as big number as possible next to it. This is maximum possible difference of two products. We can of course still use the previous algorithm, and it will give us the best possibility among positive values. Something else possible? We want to maximize. If we cannot achieve that because maybe we have too few positive elements, then what? Alright, those can be two negative elements. So minus 30 times minus 20 is also very efficient. So it will be positive times positive minus positive times negative, or negative times negative minus positive times negative. In those two cases we are very happy because always minus will turn to a plus. Sicario noticed the same thing earlier. Yeah, 3 negative and 1 positive. I agree now. I didn't see that before. For sure there is greedy here. I'm not sure if we should call it greedy, but yeah, there will be a fast solution. Well, just linear should be linear. We will find few smallest, few biggest, and that's it. One interesting constant time solution would be this, but it's cheating a little bit. It's quite inefficient among constant time solutions. Please try this problem. I'm doing something else right now. Later I will ask you for suggestions. Like a bit hacky solution. Find 4 max positive elements, 4 min positive elements, 4 zeros, 4 min negative elements, 4 max negative elements. So all the possible extremums, something. And now among those, I found here 20 elements. So try all 20 to 4th power combinations. Maybe that's actually a bit lower because you cannot repeat things. But this is theoretically constant time. This is linear to preprocess plus constant, but this constant is actually quite big. Of course, this part can be done faster, for sure, but, well, we have a linear solution. Try everything in universe, exactly, real cool. Either this, or we can figure out cases like that. Of course, still, maybe it will be positive times positive, or negative times negative, minus some two close numbers. By this I mean close to 0, like 1 times 2 or minus 1 times minus 2, just because we don't have enough elements of one type. So this same can be for negative, and maybe there are a few more cases. If else nightmare is a good description. Linear. This solution shows, by the way, how time complexity is not a perfect measure. Technically linear. No. You can argue in some other problems, whether they say, let's say, n is up to 200,000 and every element of a sequence is up to 1 billion. 1 billion is that many zeros. Then you can describe a solution, create an array of size billion and do something there. Just create this array, iterate through it, and in some way you will find anything you want. And then you will say that your time complexity is n plus size of this array a, so constant. If you want to have an array literally like this, let's say count. This is array that will allow you to count elements from 0 to billion. But you can, on the other hand, argue that this is not constant, this is max a or something like that, where this is a variable as well. Time complexity is not runtime. Yep. Generate all products in A, all products in B. What do you mean A and B? We have one sequence, and it's tricky to avoid. It is tricky to avoid using the same element. Did you qualify to CodeGem? Not to the finals, to the third round. All right, now I can move on. So suggestions are welcome now. If you suggested something earlier, just copy paste it now again. I don't want to scroll up. And today, anything from LeetCode or from binarysearch.com. I didn't use that platform for quite a long time. You can shorter the link. NG, too long of a link. I'm sure you can just copy paste some part of it. Twitch video stops every time, while the YouTube works fine. I think it will be a case for you, not for everybody. What you can do, if Twitch doesn't work well for you, you can just hear, how does it look like, pop-out chat. And you can also get the same link from YouTube description. And you can just grab Twitch chat and watch on YouTube. Is this a bonus stream? Not really. But if naming it a bonus stream will make you happier, then sure, it's a bonus stream. Yes, you can suggest a problem. It's from LeetCode or binary search. Now, what do we have? It's not code forces. Problem suggestion. Car fleet 2. Long statement and it's hard. I don't know. Also, I want to close all of that. Maybe later. What else? So I know that this is not a perfect way to choose problems, but some heuristic is just to see if the statement is short. Hacker rank I will pass. Regular expression matching, I don't like the title. I don't want to code something like that. Rectangle area 2. Is it a standard max histogram problem? Maybe this. Okay, that's one candidate. And let's see, what do we have from binary search? Well, I see that I already solved it. At least I moved towards solving it, so we will skip that one. Okay, this one, unless somebody thinks that it's very ugly, stupid something. We're given a list of rectangles. Okay, no more suggestions, guys. Too much. I need to start using Discord to grab suggestions before streams. We are given a bunch of rectangles, and we need to say what's the number of cells that are covered by at least one rectangle. Oh, coordinates are up to 1 billion. Then I think it's too difficult of a problem. Water, in a minute. I thought first that coordinates are up to 200. I will not solve this one, so in a moment I will scroll up again in the chat and find another suggestion. But if coordinates were up to 1000 or so, then the solution is to just kind of create this grid like this, initially filled with zeros. And now, slow solution, whenever you're given information about some rectangle, just mark this rectangle as 1. You know, just go with brute force. This is the time complexity of this is number of rectangles, let's say n, times size of every rectangle. For every rectangle, you go linearly through the cells. This works actually if coordinates and dimensions were up to, say, 200, because it's kind of cubic solution. Now, we want to improve this to just O of n plus the time complexity to create a grid. Then this improvement, this speed up, is thanks to two-dimensional prefix sums. Because instead of just going like that, just like in one dimension you can use prefix sums to quickly add something to an interval, then you can here, well, if you add there, subtract 1 here, subtract 1, where else? I think like that. If plus means plus 1, minus means minus 1, and now you sweep and compute two-dimensional prefix sums. So for every cell, you would compute the sum of all numbers top and left from it. Then you will get a proper grid quickly. So constant time per every rectangle. If what I described here is not obvious to you, you need to just read about two-dimensional prefix sums, or just first about prefix sums and think how you would solve a problem. This is an educational problem introducing this topic. There is a sequence of zeros, of n zeros, handle q updates, each of form LRx, meaning add plus x to all elements and positions from L to R. How can we do it quickly, not just with brute force for every update, just going through elements? If you can solve this, and also you know two-dimensional prefix sums, then you know how to do this. Three-dimensional matrix? Yes, sure, I did. I mean, there are problems involving a cube, something like that. Even Rubik's cube is a three-dimensional something. And just we often use arrays with more than 2 dimensions. So even if the statement doesn't mention 3 dimensions, you sometimes need to use that. So think about that, read about two-dimensional prefix sums, and then you can solve that. Now coordinates are up to 1 billion. So one possibility what to add is also to slap coordinate compression at the top, on the top of that. I think this is a topic you can Google as well. Code forces or gigs for gigs. And still code forces popped up. So there will be a tutorial. Not really. Oh, cube on the t-shirt. Yeah, here we go. A cube. Did I ever solve a 3D matrix problem? Like, come on, I have it on my t-shirt. That should have been my response from the very beginning, but maybe I'm not that bright. Yeah, so let's move on. Now I will scroll up to just grab another problem, because you suggested quite a few of them. Bus fare medium. How do I change this? Shouldn't Eclipse be dark? Why does it not affect the right part? Am I doing something wrong? In particular, you will not see the chat in this format. And I cannot hide this temporarily. That's bad. What do I do? No dark mode here. Sad. Well, here we go. This is dark mode extension. Do you do problems from ICPC? Not right now. Usually every stream is about something, you know, because if I just do random problems from all over the place, then I cannot attract one type of audience. So you will come to a stream and 2/3 of problems will be boring for you, and then one will be on proper difficulty. So I try to be consistent, and today I'm doing coding interview problems. So no ICPC, no code forces. Some other day I might do hard code forces problems, and to be honest, ICPC is something I rarely do. Am I Russian? Close, I'm Polish. We can hear the birds. Well, I'm happy that there are some trees outside, so yes, there are birds. LeetCode, good way to improve coding? Not better than other ways. LeetCode is fine if you want to practice for interviews. We're trying this. There are 3 types of bus tickets: 1-day pass, 7-day pass, and 30-day pass. Another well-known problem. I'm sure it is somewhere on LeetCode. I've seen this in the past. Try this with greedy? Sure. But how? How do I do this with greedy? If I see this, greedy usually means that even if the sequence is very long, then we need to decide in some way looking at first element or first few elements. Looking at one, just first element, we cannot decide which pass do we buy, because really, like, what's our idea? We always buy 30-day. So I don't really have an idea for greedy. I like to go for greedy during my streams to show you that it doesn't work, but here, what? Added timestamps in yesterday video. Oh, thank you. I will pin them after the stream. Thank you very much. Share difference between interview questions and CP problems. One difference is using segment tree. I don't know. Different topics are used. Sorted backwards, but backwards is the same, it's symmetrical. If you see that the last element is 41, how do you decide looking at 41? It isn't different. It isn't different going from the end or going from the beginning. Rita's girlfriend calling. Maybe if you post stupid comments, then she will call you. Yeah. Why is there a problem? But what greedy? What do you want to do greedily? So we look at one, or we look at first few elements. How do you decide which pass to use? The most value-based is 30. Okay, you can say that you can always use 30. Okay, that's some idea, right? So we say that, okay, whenever we see an element, if the end is not too far away, so if something like this, if a.back is greater than a0 plus 7, or maybe plus 30, we can try something like this. Then, so if the end is further away than 7 days, then use 30-day pass. And that's fine idea for greedy. Just because, of course, it has the best ratio. But tell me, in real life, is it always optimal to choose the biggest duration, you know, for this kind of pass? Well, obviously not. What if we stay less than 7 days? But what if we stay for 14 days? So for sure, if the array is like this, where we want to do something for 14 days, 2 7-day passes are better than one 30-day pass. Just if we want to do something for a very long time, then of course 30-day pass is better. But even if we do this logic, even if we have at least 30 days, it will not work. And the counterexample is if not all days are used. So consider something like that. Let's say 7, 8, and then maybe 24, 25, something like this. Okay. Now we do something for 7 or 8 days, and there could be gaps. It doesn't change much if I remove, let's say, 4. Still, there are 8 days, 8 kind of consecutive days. I'm quite sure that it will be good to handle them in format of 7-day pass plus 1-day pass. Then there is a big gap. We need another 7-day pass. This is 7. And finally 1. And I wouldn't even need this example just to assume that, well, it's not that always we need 30-day pass. In real life, we don't always choose the longest duration, and that's not only because right now I don't have money. If you have a lot of money, still it's not that you should always get an agreement for 2 years for your, let's say, internet access. If you want to move in 3 months, then don't get an agreement for 2 years, obviously. And we can think about other kind of greedy, about some logic here, but sometimes situations will not be that obvious, right? What happens if there is some kind of 13 here, 14 and 15? Now, is this enough to say that we should buy 30-day pass, or we should handle those with 1-day passes, or maybe we should handle all of this with 7-day pass? And in general, for this sequence, there are too many possibilities to just handle that with ifs. And when greedy doesn't work, the next idea is dynamic programming. So when greedy doesn't work, use dynamic programming. That's very common. And there is another reason why you should think about DP from the very beginning. This is a bit like knapsack. If you have with cost of 2, you can handle 1 item. With cost of 7, you can handle 7 items. Cost 25, you can handle 30 items. This is actually similar to knapsack, where there are items with some weight and cost, and you need to fill backpack. It's not really the same. It would be the same if you for sure were asked about all the days up to some kind of n. Then the problem would be about getting here the sum of elements with the sum of weights equal to at least n or bigger, and we need to minimize the cost. This is exactly knapsack. Difference between greedy and dynamic in a nutshell. In greedy, you make decisions looking at some part of the input, and once you make a decision, you cannot roll it back. So you greedily decide. It would be a bit like going through a shop. You enter a shop, you see one product. Let's say you see, I don't know what you can see, 1 kilogram of cheese for, how do you spell cheese? Like this. For $5. Let's say you see it and you buy it. That would be greedy. And you don't care if later there is some kind of promo, or later you can buy half a kilogram of cheese for $2. Maybe later you will see this element. There are also greedy where you would sort all the items by something, and you always choose, let's say, the cheapest or the biggest or the one with biggest ratio. But still, it's about choosing element by looking at it, maybe after first sorting. While DP is, in some complicated way, considers all the possibilities of choosing various elements. Because there will be a list of items, and for example knapsack, it is able to every element take or not, And after considering, let's say, this type of cheese, and few others, let's say there are 100 of them, Knapsack is able to combine them in any kind of pattern, any kind of total weight. If it is possible to get in total 5 kilograms of cheese from smaller parts, Knapsack will be able to handle it. And DP is even more general. But, well, watch my YouTube DP lectures to learn more about DP. Yeah, there is also this definition about subproblems, but it's very formal. When I solve DP problems, I never think about subproblems. So greedy makes a decision usually looking at a single element. DP stores information about what's possible so far, what kind of combination is possible. I guess that's the difference between greedy and DP. Now, moving on. Not from this problem, we're still solving it. Yeah, we have a sequence. And we see a 1. We have 3 possibilities. We buy 1-day pass, 7-day pass, or 30-day pass. So from this we get information that everything up to day 1, is handled, and that is with cost of 2. Or up to day 2, up to day 7 is handled. The total cost so far is 7, or up to day 30 is handled. Cost is 30, cost is 25, sorry. Those are 3 possibilities of how we can cover the first day. And for each of those possibilities, well, here up to day 1 is handled, then the next day to handle is free. So from that we will branch. And we will make some other possibilities, because then up to day 2, sorry, up to day 3 is handled with total cost of 4. What this means? Well, if I used 1-day pass here on the first day, then comes day 3, and I can also handle it with 1-day pass, and then everything up to day 1 up to day 3 is satisfied. Like I paid for those days, and the cost so far is 4. That's some possibility. Depending on what are the future days, maybe this is optimal. But also we can start in here by a 7-day pass, then everything up to day 9 will be handled with cost of 9 or something like that. And this line can be written shorter, obviously. DP up to D, let's say this is mean cost to handle days up to day B. Handle days up to D. Once we decide about some passes for prefix of this sequence, we handled some prefix, and there is cost that we minimize. The values in array days are not limited. They can be, I guess, up to 1 billion. So to be able to create this array, I will here type I. So its minimum cost to handle, let's say, up to days of I. Which means if I first buy a 7-day pass, it will handle stuff up to this 5. So DP here up to this guy will be equal to 7. And once again, if what I'm doing here is not easy to understand for you, I do recommend my YouTube lectures on DP. And maybe n+1, I will think about it later. Let's say that DP of I says that we now need to handle days of I. This is definition a little bit different than the one below, but it's very similar. This is minimum cost, assuming that we handled everything strictly before I. And there are 3 possibilities. I don't want 3 separate pieces of code, so let's handle that with one for loop. There are, I don't know, passes. There is 1-day pass for $2, 7. 30-day pass for $25. Duration. Can I suggest a problem for later? Do that close to when I'm done with a problem. Okay, now, when I start a pass at days of I, and it has some duration, then where will I end? I will end at j, while days of j still doesn't exceed this, j++, something like that. It will say what's the next element in this sequence that I need to care about because it's not yet covered by the passes so far. And this not to go out of the array. Now, j is first not covered. Like that. Specs keyboard. I don't think I have that command, but in FAQ you will find specs and keyboard. Alright, so it's certainly n+1 because at the end I'm going to return dpfn. This means that next to cover is the one at position n, not existing one. I think that's it. It's very easy to even read this from the input if this was not fixed in the statement, but instead we were given some values of durations and costs, the code would still work. Will it work or not? Interesting how much binary search focuses on those extra things in the system. Compilation error, but what kind? Why don't I see any info? Use upper bound? Yes, upper bound is a better idea. Oh, my result is 0 because by default here everything is 0, and then I minimized and I do nothing with that. I want to fill it with infinity, and just starting at 0 is allowed. I use infinity rather than int max because int max added to something, it will overflow. I try not to use int max. Done. Somebody suggested upper bound. So, you know, this is not really linear. It will go up by 1 at most 30 times because of this. Like the biggest pass we have is 30-day long. So really, like when you start from some element like 3 and you want to know where is the next one at least equal to 33, it's not that you will go to the right 1000 times. This is why I did linearly. The current complexity is, I believe, of n times 30, and we can improve it to n log n if we instead binary search, but it's not a big improvement. But sure, we can see how that would look like. J is equal to lower bound in days, where we are looking for the first value at least equal to x, where x is days of I plus duration, I believe. And if I'm not mistaken, the lower bound returns an iterator. So we need to subtract begin to get an index. Let's see if it works. Can I suggest a problem? When I'm between solving two problems, then you can suggest. Okay, so success. Interestingly enough, it's slower than the previous solution. That's because this one is always log of n, and we do it 3 times for 1 day pass, for 7 day pass, 30 day pass. So it's actually 3 times logarithm. While the previous solution, it was much simpler, so the constant factor was smaller, and we just moved to the right at most 30 times, plus 7 plus 1. So it's like comparing 3 times log of n versus 1 plus 7 plus 30 times we increased by 1. This is actually smaller. And even more, for sequence without consecutive elements, it will be faster than 30. While this new version, sure, it seems better, but it's always log of n. In this, I think I need to answer this comment. We update the future state, and in other kinds of DP we look back. I usually call that push DP versus pull DP, and I'm not sure, maybe I referred to those names in my DP lecture on YouTube. I more often use this push thing, where looking at state DP of I think this is already computed, and I try to think what are possible transitions from this state. I understand that sometimes instead what we do is we say dp of I is, let's say, dp of I minus 1 plus dp of I minus 2. So we use previous states to compute the new one. Like this is Fibonacci sequence, if you just use this formula. And this is example of what at least I call pull, where to compute state dp of I you pull values from before. And what we did here below is we pushed to future values. We modified dp of I plus 1, maybe dp of I plus 7. It's not exactly that, but something similar. Hard DP is maybe even more often solved in the push way. So in the idea, we check if taking 30-day pass is correct. No. We consider each of those transitions. The problem is that you can move by 1, by 7, or by 30, each with some cost, and I consider each of them. I iterate over those passes. Doesn't matter the order. And after considering maybe 30-day pass, I will know, oh, everything up to this point can be covered with the total cost 50 so far. I consider 7-day pass. Okay, everything up to 42 can be covered with the total cost of 38. DP doesn't decide what is best. DP for every here prefix knows what is the best value up to this prefix, but it's not that we greedily decide, oh no, 30-day pass is best. Inner while loop. Oh wait, why did I use lower bound and this? What happened? This while loop I should have erased if I have a lower bound. What do you want now? Oh, and I need to remove the comment, of course. Yeah. The while loop shouldn't anyway modify the time complexity or even the running time, because here we find this j and then we will not move it even once. That was my mistake. This was old version. It was, by the way, faster in terms of running time. This is new version. But that previous version, it was supposed to find the next not covered element. If you're looking at day 20 and you consider 30-day pass, then you want to see what's next after day 50. Can we phrase all DP problems push or pull? I don't know. Yes, there are some problems where you can only use push or only pull, or at least it's much easier to do one of them. If it was a list of size different than 3, would you change anything? No. If we could have a lot of passes, like 100 of them, still I don't know how to avoid this for loop. But if values, if durations of passes are big, then lower bound here is more important. By the way, if you want to avoid this logarithm, then 2 pointers will be enough to get linear time. You don't like using auto? I think this is easier to understand. Okay, pointers. I don't want to go into detail here. 2 pointers is enough. Right, moving on. Is binarysearch.com only for binary search? Good question. No, the name of the platform is just to confuse us. It's for all kinds of problems. Car fleet problem, maybe. Car fleet 2. Is it on LeetCode or binary search? So it's something I already considered today. Oh, it's the one I said that's too long statement, right? Don't remember now. I don't have a good memory. DP optimization sounds hard, but on the other hand, at least we will stay doing the same topic. Long statement, bet. Hillmaker. Two-dimensional matrix. Without reading the statement, I'm guessing that we want to get some kind of maximum. So maybe this problem fine. I definitely need to ask Discord server first for suggestions. When I had like 30 viewers, it was fine to ask for suggestions. Now I have, what, 240 across Twitch and YouTube, and I have now tens of suggestions. Of course, it makes me happy, but it's just inconvenient. Long statement is worth it. For which problem? Car fleet? For the DP optimization. Let's read this. If it's fine, I'm doing this problem. You're at top left corner, want to go to bottom right. Only to less than or equal, so you keep going down. You can increase height of any number of cells before you move. I think this one is fine. What was the time he got 20 viewers? Well, even now when I have harder streams, I get fewer than 100. Of course, first it was like 20, 30. So we're doing this one. And sorry, but that's the last problem of a day. Speedrun of all of them, but it wouldn't be educational for you. New feature of chat looks cool. I'm happy you like it. If you have suggestions about the font size or the duration, right now after 30 seconds messages should disappear. Maybe it should be longer, I don't know. Can you write in one go? Obviously. But that's not the point, right? We start here, we want to go there in bottom right. We can only go to lower neighbor, but we can increase some cells first. I'm quite sure that we will use the lemma that it's stupid to go in cycles. So don't visit anything twice. It will simplify things. It's not that it's forbidden, but it's stupid to do so. We don't need to care about it. If our program finds optimal way, it will not even try to visit something twice. Increase font for the chat. Also, I should maybe... Oh, it's 125%, so should be enough. By the way, is this better for the statement? Okay, so if small voting, you prefer this small font, small statement font and the code, or big? Just type small or big in the chat. This is the bigger version. The disadvantage is obviously that you see less on the screen. Medium. I don't see how to put custom value here. Medium. I guess we get half-half kind of. Yeah, so 125% should be enough. There are more votes for big, but it's not huge majority. Maybe now it is. I guess I can go big for the time of just talking about it. And the chat will, I think, stay like this. Just, I don't want to pollute the screen more. Stream Parrot, what is that? Powerful branding. Create the ideal chat overlay experience. I don't want anything custom or complicated. Right. Lemma is actually that optimal algorithm will not even try to visit something twice, I hope. So we shouldn't, it's not that we will want to remember our steps so far. That would be very complicated in any kind of, BFS, Dijkstra. There is total cost, so this will be Dijkstra problem. We have a graph, we can make moves along edges. Edge is always to a neighbor, and there will be costs of making a move. This cost will not be trivial, but in such a problem, the graph, there are edges with and some costs bigger than one, we use Dijkstra. So let's go. Idea, use Dijkstra. I still don't know how. It can be solved by Dijkstra just in distance array. Yeah, I think it will be Dijkstra. The cost is obviously changing stuff. Just when we are somewhere, let's say in Dijkstra we are now at cell I equal to 2, j equal to 0, and the total cost so far is 50. And we consider going to our, say, right neighbor. How do we know if we should increase something? Well, increasing means that if right now a of ij is, say, 15, 17, our neighbor is 19, we cannot go there. And you might say that we just increase 17 to 20, or to 19 is enough, because equal is also fine, if I remember correctly. This is not LeetCode. Yeah, I cheated a little bit in the title. Today I'm mixing LeetCode with binary search. LeetCode is so easy that I changed the platform. Let's leave it like this. It's the same. Binary search has maybe a little bit more interesting problems. Sometimes they are harder. This is not 0-1 BFS if we can sometimes get extra cost of like 20. Oh, this constraint. I see. I see. I think we will use this constraint. I will finish my thought. Here I tried to make it n times m, but with those constraints I bet that Dijkstra will not work. And instead I will need to use this constraint. Money makes us do so much stuff. Why? How? Money made me switch to now solving a problem on binary search. All right, I plus 1. Okay. The bad thing about this is that we came in some way to this cell. So there was some previous guy, and maybe this is a bad example, but say this one is 29. Now, if you increase this to 29, maybe your previous steps need to be increased as well. So if we want to use this is not a way to go. If we start from top left, we cannot say that there is some cost for moving from a cell to neighbor, because it affects all our previous decisions. Instead, maybe we should go backwards, because then when you so you go from bottom right and you are in some cell, let's say with value 40. Now you see a neighbor, and backwards you can go up, right? Yeah. So backwards, this would be fine, you could just go there. But if it is like this, then you need to change 35 into 40. But you don't modify your previous decisions. So backwards makes more sense. This is more promising. But still we will have ij cost so far, but it seems that we need the current height. Those are two separate things. It's not that I maximize just one of them or minimize the other. There can be there will be some trade-off of what's the total cost so far and what's the height of this current cell. Didn't say I disrespected, I just said we all work hard for it. No. You didn't say that at all. You said money makes us do so much stuff. It seems to be very unrelated. Thank you for your lectures. You're welcome. I'm happy it was useful for you. Yeah, I didn't previously notice those unusual constraints. It suggests that we'll have state, like for every triple ij height, we will do something. And then it's easiest to, maybe it will be Dijkstra on those states, or Dijkstra is also some kind of DP, or DP of those. I'm not sure which will be easier to think about. But in Dijkstra, for every state like this, I want to know, to be in this cell, ij, at height h, say h is enough, what's the total cost so far, what's the minimum possible total cost so far used to get here, to this state. For DP, well, it would be the same definition. Dijkstra and DP are the same. Isn't Hillmaker equally same as this? I don't even want to open the statement, but maybe. How to understand constraint? Well, the constraints will tell you what's fast enough and what's not. And also they are here for some reason, so this suggests that the time complexity is n times m times h, maybe multiplied by logarithm, maybe not. And now from this time complexity you can think about algorithms that will give you this time complexity. Dijkstra is DP. Dijkstra is DP. Dijkstra doesn't make greedy decisions. It, for every state, knows what's best for that state. Okay, can I do it with DP without some priority queue for Dijkstra? Sometimes we'll use the same height. That's ugly. If we could only use to a lower neighbor, it would be something like this. For h decreasingly, for h like this, for every I, for every j, we consider going from this state to all the neighbors, in particular, let's say to the left, or like to the left, assuming that I is column. And I can say what's the cost here. So this is possible only if this left cell is not higher than this, and then the cost is by how much I need to raise it to be here. So it's easy to say what's exactly this line. Like this refers to if the initial height, that's matrix of I minus 1j, if that's not higher than h, not higher than dp of I minus 1j h is minimum of itself, comma, that's my dp state, plus what? I raise to this height. Okay, and you will have 4 transitions like this one. Can be done with a single for loop. It's not that difficult to iterate over 4 directions. And then there is also a possibility of raising this cell, I think. Or not. Oh, yes, it is possible. So dp of ij h plus 1 is minimum of itself, comma dp of ij h plus 1. And actually this shouldn't be plus 1, and this also shouldn't be. H shouldn't be the height, but which height it is. They said that not the height is up to this, along with nm, but h is the number of distinct values in matrix. So if the heights available in the input are 10, 50, 60, then h equal to 0 should refer to 10, 1 should refer to 50, and 2 should refer to 60. Something like coordinate compression. H equal to 20 actually represents height of 60, because that's second lowest in the input. Lockout versus William, part 2, I've improved? I didn't improve. LeetCode using Python? It would be a challenge for me, and sometimes I would write stupid shit, so maybe. Okay, so this would work if not for equal values. Equal values make it possible to go through some connected component, back and forth. So it's not really that we just go from h. Oh, even here it's an issue. Yeah, we have cycles there. So this is not correct, because I cannot possibly get a correct order of moving through cells. Instead, we need to use Dijkstra, or at least some simplified Dijkstra for that. Okay, so back to this idea. It will be Dijkstra on states ijh. You could use dp like this, iterative one, only if you knew the order of visiting cells. So Dijkstra on those states. You obviously start from 0, 0, and whatever is height at 0, 0. Start at here. And there are edges, like from ijh. There is an edge to I plus 1 jh with some condition, and the cost is like h minus matrix of I plus 1 j. Right, from ijh there is an edge to ijh plus 1 with cost of 1, or actually cost is, I explained here why it's not exactly 1. H is one of those values, 10, 50, 60. It's difference like 60 minus 50. So yeah, and that's it. I wanted to get a solution without Dijkstra, but I failed. That's the solution, what I marked here. What site is this? binarysearch.com. Why DP fails? Because you need to get, if you want iterative DP, you need to choose some order of for loops from, let's say, I from 0 to n minus 1. But well, then it will not work. The transitions need to be only forward in terms of states. Binary search is Discord. Yes, it is. But this design comes from the fact that I turned on an extension of Dark Reader. Do you not have to increase the height of all cells visited before? At the very beginning I said that actually it's stupid to visit something twice, so let's not care about it. I can be mistaken here, but I think it will not be an issue. Though it's not trivial to say why it's not an issue. Tutorial for coordinate compression. I don't know anything at the top of my head. Yeah. So forget about the DP. It doesn't work because if this you iterate increasingly from 0 to something, from 0 to something, then you cannot, being at position I, modify I minus 1. The edges can only go forward. That's a general true statement. In DP, if you have some order of computing states, edges can only go from one state to the next one, to something that you will consider later. And that's it. This is not really very interesting to implement. This, right? That's the solution. Let's move this away. And complexity. I wanted to avoid log, but I can't. This is the number of states, and obviously Dijkstra yields another logarithm of, I guess, just this. Twitch stream is little ahead of YouTube's. Ask Twitch and YouTube. Apparently YouTube uses different codecs, coding and encoding. I guess trade-off of quality versus speed, maybe also resources. You can increase value of some cell. We can traverse an edge if value is this, not neighbors. Isn't it true that we should only increase our value if we are lower when going through the edge? When you go from one cell to another, let's say from ij to I plus 1j, in order to do that, you need to modify one of them. So what? We go down, right? Oh, and we already said, if you say that when going like that, you say ij needs to be increased, that would be bad because you mess up previous states. Like previous moves could become illegal, and we don't want that. So yeah, all of this we do backwards. We actually move from low to high, and then we can say that when I go from lower to higher, I modify this new state. So start actually should be at n minus 1, n minus 1, and value there. Starting bottom right. Okay. Dijkstra on those states. What? Oh, the constraints were originally different, so we shouldn't worry about that. But yeah, I think they have states x, y, height. Yeah, that's the time complexity. And now the chat, I guess, is impossible to read. Need to remember about it, and sometimes when I read this thing where the width is not smaller, I should just do this. Well, anyway, sticky notes to code, magnets on the refrigerator. You can use your light bulb and do some, when you switch light on and off, that's 1 or 0, you can code like this. Can you read carefully too? No, because I wouldn't have time anyway to comment. Sorry, I need to go. Thank you all for watching, and see you, I guess, on Tuesday. Whenever I modify my schedule in some way, I keep this updated. To the best of my knowledge. Sometimes, anyway, last minute I would change something. Happens. Right. Hope you enjoyed this and learned something. See ya. Bye. I will check on Twitch if somebody is streaming interviews. Nope, I don't think so.